Hello students, in this video I will be explaining you the logarithms, its properties and how to use logarithms in solving the sums. Watch this video till the end. I have solved some questions in the end of the video. As usual, if you have any doubts and clarifications, please feel free to put in the comment section. And if you have not yet followed our Easy Exam Academy channel, please do subscribe and click that bell icon. Let's get into the video. Logarithms are an important concept in physics, chemistry, as well as mathematics. It is very important to know the concept of logarithms. What is a logarithm? Fractions can also be represented in terms of decimals. For example, we can write 1 by 2 as 0.5, 1 by 3 as 0.333 or 0.3 bar, etc. and etc. So fractions have another different form of representation called as decimals, right? In the similar way, exponents have another different form of representation, which we call it as logarithms. Logarithms are essentially exponents disguised in some other form, like fractions are disguised in decimals format. We define logarithms like this. B power x is equal to a can be represented as logarithm of a to the base b equal to x. The b letter is called as base and a is called as value and x is called as the exponent in logarithms. To easily remember the logarithm to exponent conversion form, I will be teaching you a method. That method is called as the hat method. Imagine that the base b is a guy and x is the hat. You just put the hat on b and you convert it to the exponent. B is the guy. I am putting the hat on b, that is x. I am sending it right side, which will be equal to a. This method is called as the hat method. For example, if somebody is giving us log of 1000 to the base 10 is equal to 3. The exponential form of this is you send the 10 like this. So 10 power 3. 10 is the man and hat is 3. I am putting the hat on the man. So 10 power 3 is equal to 1000. 10 power 3 is equal to 1000 is represented as log 1000 to the base 10 is equal to 3. We need to pronounce it like this. Log 1000 to the base 10 equal to 3. Properties of logarithms. There are 4 different properties of logarithms which I will be explaining one by one. The first rule is called as the product rule, where log of m into n to the base a equal to log m to the base a plus log n to the base a. This rule is a disguised form of x power m plus n is equal to x power m into x power n. It is a disguised form of this exponents rule. Next comes the quotient rule. Log m by n to the base a is equal to log m to the base a minus log n to the base a. It is the disguised form of x power m minus n is equal to x power m divided by x power n. Then comes the power rule. Log of m power n to the base a can be written as n into log m to the base a. Then change of base rule. Log a to the base b can be written as log a to the base k divided by log b to the base k. The k can be any number. This is the change of base rule. So these 4 rules are very important when we are considering logarithms. It is because of these 4 rules only logarithms play a very important role in calculus and other mathematical parts. Next, why logarithms? Logarithms are widely used in calculus, physics, and chemistry, especially in chemistry when we are calculating the pH value. pH itself is defined as minus log of H plus ion concentration. So logarithms are basically used everywhere in science and technology. The most important use of logarithm is to simplify the calculations, because logarithms can convert the multiplication to addition and division to subtraction and powers to multiplication because of the 4 previous rules that we have studied. For example, let us consider there is a very big calculation like this. We are asked to find x is equal to 0.3456 multiplied by 1.2345. It is very difficult to do in normal method, right? So what we can do is take logarithm on both sides. Log x will be equal to log of 0.3456 multiplied by 1.2345 And by using the product rule, we can write it as log of 0.3456 plus log of 1.2345. From the log table, we can find these values easily. And write down. So this value comes out to be minus 0.461442, and this value comes out to be 0.091491. If we add, we will get log x is equal to minus 0.369928. To find out the x value, we can take x is equal to anti-log of minus 0.369928, which comes out to be 0.42665025, which is very close to the multiplication answer. If we do this multiplication in normal calculator, we will get the answer to be 0.4266432. So which is very close to this answer, right? This is why logarithms play a very important role in calculating hectic calculations that arrive in sums related to nucleus, etc. in physics. The log values and anti-log values are readily available in a table format, which they sell in the stores. They commonly call that book as Clark's tables, which involves all the trigonometry, all those values are there in the book. So by using the book, I have calculated these values and I have found it out. Next, the type of logarithms. Logarithms are divided into three types. One is called the natural logarithm. Natural logarithm, the base will be e. E is nothing but Euler's constant that's an irrational number like pi. Log m to the base e is written as ln m. That is pronounced as ln m is pronounced as ln m. All the questions that you do in differentiation and integration, wherever we see logarithm, that means it is a natural logarithm and not any other logarithm. So in differentiation and integration, generally in calculus, when we take logarithm, always remember that is a natural logarithm. You are not taking any other normal logarithm or binary logarithm. The second type is the common logarithm. Common logarithm is simply written as log m, like that, where we need to assume the base to be as 10. The base is assumed to be as 10. Simply if we write log 2, that means log 2 with respect to the base 10. Then binary logarithm, that when the base is equal to 2, we will be writing log m to the base 2. That is a form called as binary logarithm, which we'll be using in the computer science related questions. The most important thing to understand in logarithm is that log 0 is undefined, and similarly log of negative numbers is also undefined. I will tell you why. Consider log 0 to the base a equal to x. Then by using the hat method, a power x is equal to 0. Will the exponent a power x become 0 for any value of x? It is not possible, right? A power x can never be equal to 0. It will always be a positive number. So that is why log of 0 is undefined. Similarly, if I take log of, let us say, minus 2 to the base a equal to x, a power x is equal to minus 2 by using the hat method. Can a power x be a negative value? It can never be possible. That is why log of negative numbers is not defined. While doing the domain calculations in functions, we usually make it as a constraint. Like whenever square root is there, we will not allow negative numbers to come inside the square root. And when 1 by x is there, we automatically say x will not be equal to 0. These are some constraint in mathematics, right? Similarly, logarithm, if I am defining logarithm of x, x will always be strictly greater than 0. X cannot be 0. X can never be less than 0 also. And logarithm of a to the base a is equal to 1, because let us consider log a to the base a equal to x. A power x is equal to a. The value is x is equal to 1. So this we need to remember. When we draw the graph of logarithm, it is always an increasing graph. Also a point to remember is log of 1 to any base. Let us find out the value by using the hat method. A power x is equal to 1. X should be always equal to 0. So log 1 is always equal to 0. Remember that. So when x is equal to 1, it touches 0 and it never goes beyond the 0. It is undefined. At 0 also it is undefined. So the logarithm value comes like this. The graph of logarithm comes like this. So when log of, if I am taking a number between 0 and 1, the logarithm value will become negative. For example, if I take logarithm of 0.5, it will come in a negative value. So let us see some examples. Solve for x. Log 4x to the base 2 is equal to 5. So by using the hat method, I can simply make it. So 2 power 5 is equal to 4x. 2 power 5 is nothing but 32 is equal to 4x. So x is equal to 32 by 4, that is equal to 8. The second question, log of 81 to the base x is equal to 4. So by again using the hat method, x power 4 is equal to 81. X power 4 is equal to 3 power 4. So we can tell x is equal to 3. Hope you have understood about the logarithms in this video. If you have any doubts, please feel free to post in the comments. And if you have not yet subscribed to our channel, please do subscribe and click that bell icon. Thank you.